Okay, I just want to do a short video on how we can use this understanding of molarity and volume, how to calculate moles when we're just talking about ions. So it's a little bit different now that we know what we know about dissociation. So the first problem here says how many moles of silver ions, so we've got silver ions, are present in 25 milliliters of a 0.75 molar solution of silver nitrate. So to solve a problem like this, the first thing I'd want you to do is to write that dissociation equation. So silver nitrate is actually Ag, that's silver. It has a +1 charge. Nitrate is NO3, and we know that that has a -1 charge. So that's going to break up into silver ions and a nitrate ion. So here's my plus, and here's my nitrate ion. Okay, so I wrote the dissociation equation for that. Okay, now if you notice that it's asking for moles, so it wants to know how many moles of silver ions we have. So this is actually what we're going to solve for, is the moles of silver ions. We were given a volume and a molarity of the silver nitrate, so we have to figure out how many moles are in this amount of this concentration. Okay, so to do that, I'm going to just plug in what I know. I know capital M stands for moles per liter. So I'm going to type in my moles per liter. And let's see, so this means this is 0.75. And X is what I'm going to be solving for. So that's the numerator. And then that milliliters has to be in liters. So let's see, 25 milliliters is 0.025 liters. And when I do that work, X here is going to end up being, oh, what did I get? 0.0, we'll say 2 sig figs, it's 0.0190 moles. So 0.019 moles. That is how many moles, I'm going to put a 0 in front here too. Okay, that's how many moles I would have in 25 milliliters of a 0.75 molar silver nitrate solution. So now, if this is 0.019 moles, we know that the silver concentration, this is the silver ion, would also be 0.19 moles. So your answer would be 0.019 moles of silver ions. And that would be your answer. What if I asked you the total number of moles? So, what if the total number of moles that were in solution? Well, I'm going to just do this in another color just so that we can kind of differentiate. That would mean if this dissociates, there's 0.019 moles of silver ions, and there would be 0.019 moles of nitrate ions, right? So that would give you 0.019 moles of the silver and 0.019 moles of the nitrate. You would add those together. And that would be your total moles that would be available. And that's for the nitrate ion. Okay, my trackpad is doing weird things on me again. So I'm not even going to add those two together, but you would add those two, and what does that give you? 0.038 moles total in the solution. Okay, so what I want you guys to do now is I want you to try. So I want you guys to calculate the number of moles of chloride ions in 1.75 liters of a 1.0 times 10 to the -3 molar aluminum chloride. I want you to pause the video, I want you to do the work, and then when you do the work, you can turn the video back on, and we'll look at your solution and see if it matches mine. Okay, so here is the solution. The first thing you would have to do is to figure out how many moles of aluminum chloride you have. So you use your molarity right here, and you'd say, okay, I'm going to plug in what I know. I know this is 1.0 times 10 to the negative 3 molar. This is moles, X, that's what I'm solving for, and this is the volume, which is already in liters for you, and you come up with 0.00175 moles. So that means you have 0.00175 moles of aluminum chloride. When that dissociates, you would have 0.00175 moles of aluminum, and the chloride ions would be 3 times that amount because of this mole ratio. See, it's a 1 to 3 relationship. So you're going to multiply this number by 3, as I'm showing here, which gives you 0.00525 moles of chloride ions. And remember, the bracket means that's the concentration. So whenever you see bracket and a substance in it, you should say, okay, what is the concentration? That means concentration of whatever's in the bracket. So it's an abbreviated way of saying concentration. The bracket means concentration in moles or in molarity, okay? And actually, now that I say that, that's not at all what I was looking for, was concentration. So the chloride bracket would not apply here. It's actually just wanting to know the number of moles. So let's take that bracket out, okay? So we won't even put the bracket in. I'm going to actually take that bracket out. We don't need it because they were actually in here. Of course, my trackpad's doing goofy things. We don't need the bracket because they were looking for the number of moles, okay? So that would be it, okay? I hope that helps. Have a great day.